erupted there in 2010 called Ideafiala. Okay. Anyway, that's right on the flank of that volcano. And alpine plants are sensitive to climate change, and this is well documented. I didn't have the space to put in a lot of references here. And I can tell you the names of them if time allows, but you can use them as indicators of the effects of climate change. So they can be bioindicators. How are these ecosystems responding to climate change? They're not direct measures of climate change. We can measure that with various instrumentation, but you can see whether these plants are surviving. And this is a rare Arctic alpine plant that grows up at Glacier National Park. It's the pygmy poppy. Cytax. Oops. Okay, another project I'm involved with, as are many, many people, probably about 1,000 people, is GLORIA. It stands for Global Observation Research Initiative in Alpine Environments, hence the acronym. But it's a network of mountain, plant, and temperature monitoring stations around the mountain ranges of the world. And we have one in southwest Montana, up in the Pioneer Mountains, which are southwest of here a little ways. And then a spin-off from that is the tea composition project. This is the top of Mount Fleecer, which is a nearby summit. It's very rocky up at the top, and what we do is, it's very peculiar, but we have placed tea bags in the soil at various places on the mountain. Then we come back and get them, which is tricky because it's a little tea bag in the mountainside. The reason is because working with around 300 other people, we are looking at nutrient cycling and rates of leaf decomposition, because tea is made out of leaves. Everybody puts the same kind of tea, and it's standardized. And then there's the RAPT project, and this is over in Scotland, called Researching Plant Functional Traits. And here I'm working with a modeler and some scientists over in Scotland to look at, make a predictive model of responses of plants to climate change. And then Glacier National Park Snowfield Plant Project, looking at responses of plants to climate change. And thanks. Okay, there we are. Okay, so I think now we have Robert coming up. Okay.
Robert Powell is my name, and you might notice that I have an accent, and that comes from Hungary, from Central Europe. It's Eastern Europe, some people say. And basically, this is the title of our session that I think was originally said agriculture and eating plants in the context of climate change, sustainability, and restoration. Basically, you see a picture here with my name, that I also work at Montana Tech and at the same department as Marta does, and my main function there would be teaching restoration-related subjects. My history, however, brings me back to work on weed species back in Europe mainly, and also invasive plants in Europe and in North America. So what the outline of this little talk would be is basically bringing you two examples. A European example where weeds, I will actually study or show you or study weeds in intensive and low input agriculture systems. And I feel that it might need some explanation, but I think the first picture will reflect on that. And I will put in some of the effects of the climate change on these systems, on the weeds and those different low and high input systems. And then I will talk about ecological restoration, basically here in Montana, and the effects of climate change. So the first study would be weeds in Europe, and I hope you don't mind that I bring something to you that is not an example from the States, but I think it's actually very nice and very informative in a way. So I was talking about high input or intensive and low input systems, which would mean, of course, high input of all the resources of chemicals, the fertilizers, herbicides, and And you will see these fields. This is actually, these pictures were taken in Italy when I actually worked on a big project over there. And you can see these tracks of the tractors which are ameliorating these fields, just putting a lot of stuff to it. You can see no weeds basically. And the other thing would be the low input systems, which would have small parcels all over the place, and will have a lot of different weeds, a great diversity, very beautiful land. And you might wonder, well, can people actually produce there something? Well, yes, I must say, because they proved for thousands of years that they can actually just supply the local community there with these low input systems, and even with the diversity of weeds that they actually have there, and they benefit from those weeds as well. They're not just pests taken as you need to spray them out, because they will just take the energy from your soil away. Of course, if you start already a high input systems, you will get weeds that you don't want to really have. But anyways, these fields back in Europe are actually ranging from really high, almost like alpine systems, down to the sea level. You can actually see the Mediterranean Sea and the cereal field, and I'm focusing now on cereal systems in this study and its weed compositions. And basically what we did was to survey these fields, and I'm still envious or kind of jealous to that thing that I did that and I'm not there anymore. You can see these medieval places, and you just you can see all these little parcels. Some are intensively, some are, I would say, extensively managed. And we did collect hundreds and hundreds of plots, knowing what the system, the growing system for the fields were, and collecting that in the low input and in the high input systems for weed composition mainly. And basically, I told Robin when I designed it that I won't show really crazy figures and graphs, and I'm not really going into that. But what we first found when we analyzed the data, of course, you can imagine, of course, no weeds, lots of weeds, and you can see that if we actually analyze them in a cluster analysis, which takes the weed composition of different fields into consideration, they will be really well separated. So that's a big thing that you can right away imagine. We also collected a lot of large-scale data on those fields, not just how they grown the cereals, but also what climatic conditions were, what the elevation was, what the slope, what the aspect of these fields were, and we were wondering whether they made an impact on the weed composition. And basically that's my last figure that I'm showing you. And this is crazy, I didn't like them when I actually first handled these graphs, but basically what you see, empty circles mean the invasive fields, and full circles would mean the extensive fields. Right away they separate it really clearly. And then you see the different effects in this three-dimensional model: precipitation, altitude, humus content of the soil, soil texture, temperature, so on. They all had different effects on the weed composition. And that's the main message. We actually figured, of course, that they will be actually really significant on some of these weed compositions. And I'm sure that's a little high up there, species composition. And the low input fields for species composition actually had 58 characteristic species out there that actually suggested us that they indicated some kind of background condition. Could it be the distance from the sea? Could it be the elevation and all kinds of things? So we could actually name 58 species out of hundreds that help us to characterize these systems. And here are just a couple of the pictures. They're very beautiful plants. And in the US, there's also a lot of weed species. The big problem is that most of them, of course, came from Europe. So they're not just weeds, but they're exotic too. So you don't really want to have them. But we know that there's different types of weeds too. It's not just the newcomers and European invaders or Asian or whatever, but there are species that are so-called pioneer species that also can influence our fields, and there should be the species that can suggest us something in these systems that the ones back did in Europe. I also must say to you, I put these pictures in because most of these plants actually, this actually is called Scandic spectrum veneris. It's from a family where the umbelliferae, the carrot family, I think that's how it's called. This species was already extinct from Hungary. And I must tell you that species that are harbored by these cereal fields, sometimes these are the only habitats for these species. So back in Europe, there are movements to actually protect some of these extensive fields, to protect the species. We don't want to lose them. Because they're actually followed us in our route from like early agriculture to late, and it's kind of our duty to do that. With the high input fields, we actually didn't have too many, only 2 characteristic species that suggested something. And those were also invasive, like exotic species, one of the little helianthus, the sunflower. And with that, I just would like to reflect to climate change, because there's also an exotic species, it's a sorghum species, comes from Asia to Europe. And this actually moves from the south to the north. They also actually estimated the speed of basically the spreading of the species. It actually spreads by 50 kilometers per year from the south to the north because of presented climate change functions. So that there's areas it could not exist before because it has a rhizome, which is really a juicy rhizome. So if it's really a frosty cold period, a cold winter, it would kill everything. But now, I came from South Hungary. When I was a kid, that species was not there. And it was not there because we had colder winters. And now we have milder winters, and the species actually is now kind of heading towards Slovakia, which is bad. Anyways, it's a bad agriculture weed, there's resistant forms of it, so even with crazy herbicides, it's hard to protect them. We found a relationship between elevation and species number. The higher the cereal field was, the more species it had. It was true for both the low input and the high input fields too. And then a really important thing was that many of the species, indicated something, and I could bring you now a big list, but I think it's much nicer to actually demonstrate it with pictures. So this daisy-like flower, which is an anthanis, actually indicated the distance from the seed, higher precipitation and lower temperature. And a larkspur species, Consolida regalis, and one of the viola species, Viola, I'm not sure if it was even arvensis, but one of the viola species from the Mediterranean. Indicators for lower altitude and distance from seed are these guys. There's also a cheatgrass-looking plant, it's called Bromus matritensis. And another anthemy species, you can see its lower head, it's kind of pointing upwards. So why are weeds actually important? Why could we actually think of any use of them other than just killing? So this is a nice cereal field. Probably you don't want to have that. Back in eastern Hungary. And here are some of the benefits. One of my earlier mentor and I wrote a book about basically the benefits and all those really rare weeds. And there is a lot of literature behind it that these weeds are still today used for food and fodder, medicine, for dyeing. I hope I'm pronouncing that good. Bee forage, really crucial. Bird food. That's something really crazy. People like to hunt, and why is there less Hungarian partridges out there, or why is there less other birds out there? And it's because they don't have, if these weeds are not out there, there's no insects on them, there's no grain, whatever the seeds of these actually species can provide them, and they actually leave these habitats. The big agro-deserts are completely uninhabitable for species like that. Species diversity is also an important thing on the fields, and habitat indication. I told you already that they can indicate several things. This is just a German example, but in the EU there's movements that basically these fields are evaluated by scientists, and they actually get some protection. Basically, how would you protect a cereal field? Basically, you actually need to tell the farmer, hey, you actually should do the same thing that you did so far because your field looks awesome with all these flowers. And then from the EU, they get money from the loss of the grain they actually can lose from the plants. And so they're encouraged to keep these diverse fields there. And they have this emblem there that means art and Vielfalt is leben quality. It means species diversity, it means quality of life, something like that, which is, I think, really true. Anyways, that was one of the big chapter, and I have maybe 2 more minutes.
Yeah, you're fine, actually, if you want to.
Yeah, just let me know when I should finish, because this I can finish it.
Those all
Most of them were annuals or sometimes biennials, because other life forms, if it's, perennials, they should be rhizomatous, but usually they're not great species most of the time. So the ecological restoration in high elevation arid ecosystems would be the other thing that I actually have now a position here at Montana Tech, and that's our main duty. This is here in Butte. Isn't that wonderful? Anyways, this is one of the article lands that was probably part of it was capped, part of it just wasn't even capped. It just renaturalized. And this is the system where we need to do ecological restoration. And I always ask my students when I'm teaching this, what is restoration? And it's, of course, if I'm telling to someone, what are you doing? I'm doing restoration. Are you restoring buildings or furniture? No, I'm restoring ecosystems and trying to bring them back what they were, but that's not really correct because restoration today is not exactly doing this. But if you look back in literature, the act of restoring a former state or position. So if we actually have a mining landscape like here in Butte, what restoration would mean, bring back something that was here before about 100 or 150 years before. But how would we know that? So we have a picture from 1875 from Butte, which is one of the earliest pictures taken. Would you actually be able to recognize, would you be able to collect data, what to do as for restoration? I bet it would be really hard. You wouldn't even know that these were woodlands or were just natural prairies. We don't know. So therefore, what we do here, we try to follow a model that is called, I will tell you, so if we here are in the present and we would like to do restoration, we would need to bring our ecosystem back to the past with everything. But we don't want to do that today because it would be silly. We don't even know that there's changes, like climate change is really important. There was already some recorded changes ever since. So why would we want to do that? So we actually are following a so-called moving target, which is today in restoration. How would you do that? You need to go out and look at what the pristine systems or kind of last disturbed habitats can actually provide you and survey so-called, you can say reference sites or reference models, because it's not exactly what you can bring back there. And based on our work, basically, this is one of the examples on a plateau near the Big M, where we actually collected a lot of data, and silky looping prairie jungla, blue wheatgrass would be the species that are most likely to be there. Anyways, and you should do that on a salt slope and different soil conditions, lots of things, and then you can have an idea. It's also important to take into consideration that not only the species are important, but the successional phases. You cannot start with a late successional species that is somewhere and it looks great and you should put a lot of Christmas tree, for example, to a site. You actually should know which are the pioneer species. And I wouldn't say they're all pioneer species, but we try to focus on them. And if we go out to sites, we should see what comes after a big burn. And we know that lodgepole would be a really significant species, and some of the junipers and aspen is a couple of the habitats. But anyways, here are some of the species. We also try to collect seeds or cuttings, and the red framed ones are also nitrogen fixers. And that's also really important. And it's very interesting. It's not only the pea family, but we have Mount mahogany, and we have bitterbrush, which is also a nitrogen fixer. We try to seek for species that are handling the contamination levels well, and try to bring back something like that. Anyways, I just go quickly. We try to collect the propagules and grow them in the greenhouse. These are cuttings of junipers, thousands of them, and that's what we use for our restoration efforts. And this is like 10,000 or 15,000 plants in different pots, which are ready to put out to the Butte Hill and diversify the system, which is actually now agricultural grasses, mainly crested wheatgrass, which is a really hard coal. And this is one of my last slides because I really feel like I'm taking too much time. Mycorrhiza, we also need to talk about that. And in restoration, I'm glad Mark already introduced that, so I'm not talking too much about mycorrhiza did. But we are applying mycorrhiza. This is one of our students and checking the growth and the survival after a mycorrhiza application and control situations. And this is one of our babies that we actually mycorrhiza colonized. And it looks like it's sick, but it's actually the mycorrhiza growing on top. On the roots, and it's actually just creating a huge surface of roots basically for the plants, and this is good for dry tolerance, for taking up minerals, better survival for sure. This is one of the studies that, one more graph, that's actually a couple of species, Artemisia tridentata without and with mycorrhiza, Aster occidentalis without and with mycorrhiza. You can see that these differences, there's no stats now behind just to show it to you. So these pairs, most of the times, especially here, there might not be even actually mycorrhiza even related to it, or we didn't find the right partner for it. But anyways, mycorrhiza is really cool and it's very important in agricultural systems and in restoration too. And that would be my last slide and kind of a take-home message that going with agriculture is crucial to sustain species diversity. Certain wheat species can be beneficial. Climate change influences distribution of wheat species. Moving target is a different, really important approach in restoration. Locally adapted species and mycorrhiza is also something we want to do. And with that, I would like to thank you. Sorry.
My question is that there were weeds in the cereal field that looked like poppies. And was that actually something that they were harvesting and then and also processing, like with the weeds, like were they having to sort that, or was it just like they just let it go?
It was actually just let it go.
Okay.
So poppies are one of the weeds that are only coming in these low input systems, and farmers usually don't really like it, but the public loves it. It's like doing restoration. You're not doing landscaping, but with this, they actually grow stuff that they also do landscaping for the fields in a way. And I must tell you with poppies that it's one of the species that the human created. We don't know where it really comes from. There is not a wild variety or wild partner for it. There's no habitat that harbors that kind of poppy varroas. It actually, the scientists with now genetics can actually track down that it was probably created by several poppy species, and it only actually inhabits human influence areas. Only cereal fields around human, and that's it. You won't find it anywhere else. So it's our species, our baby.
So the grain isn't used?
The grain is used. But then with that, poppy seeds are so tiny, so but even with the most primitive system that selects the seed through, the poppy will fall out right away.
I thought I saw in there as well. Was I seeing wheat and poppy in there?
Yeah, it's wheat. Sorry, so it's on the edges, so it's a wheat field, but it's actually has an infestation of the poppy. Sorry.
But they're still harvesting.
Yeah.
Wheat?
Oh, they do.
Thanks.
Sorry.
All right, and you had go ahead.
Actually, I'll start with one for Dr. Alpine. You've been doing a lot of these beautiful studies with the Oregon Project. So what kinds of conclusions, or at least what is your data showing in terms of sort of high altitude effects and their response and change?
Okay, well, there's the word thermophilization, which means that in Europe, we don't have all the data tallied for North America yet. In Europe, what's happened is that we're seeing greater abundance of heat-tolerant species on mountain ranges, and more so in the southern part of Europe, where it's hotter anyway. So we are, if you remember from my talk, I showed the picture of the pygmy poppy, and the pygmy poppy is a mountain plant, and it's one that lives up there and is likely to be sensitive to climate change. So when you see different species coming in, you can look at their heat tolerance ranges and see that, oh, okay, we've got some warming up, and we've also got plants that are more tolerant to warm conditions, and they may be displacing the plants that would usually be there. Also, when snowfields and glaciers retreat, they don't have as big of an edge, so there isn't as much water available. So you get plants that are more adapted to drier conditions too. Let's see, so that's essentially it. So did that answer your
Well, and it's sort of tied in tiny animals that use those plants for food. If there's a particular flower that blooms and the typical insect that pollinates or bird that feeds on it, if they don't have their timing synced up, somebody's screwed.
Yes.
Are you kind of seeing how this part of the
Yes, it's called pollinator mismatch, and what can happen is that the usual pollinators, if you have really specific pollinators, that means an insect or a hummingbird will only visit a certain type of flower, it's got to match. Or you have more generalists that can pollinate a wider range, or that the plants can be pollinated by a wider range. You've got a little more leeway with the system, because the chances for it working are greater, and the number of possible ways of it working are greater. So, yeah, it's happening. One thing tying this in with what Robert had to say is that in the places I've been studying mountain plants, we don't have weedy species up there that high. It will be very interesting to see what we get over the coming years with climate change in the high mountains if we've got an influx of weeds, because many plants can reproduce sexually and asexually, and ones that have rhizomes can reproduce asexually, and they form clones, and they can advance very quickly, and can do so. Ones that are more heat tolerant, weeds that are more heat tolerant can advance more quickly with warmer weather. So we might see some change up in the high country for that too. So.
Are those low impact human knowing areas or low? Is the impact increasing of human?
It's increasing. It's indirect, very high impact because of climate change. But direct impact is fairly low, except for trails and social trails, which are a phenomenon in mountain systems where you have one designated trail, but someone walks off, I'm going to walk up here, someone else sees that, walks up there, another trail gets started. And there are a lot of these in our national parks, and that leads to more trampling in sensitive areas. And to work there, we have to wear, at Glacier Park, we have to wear these orange vests, and it's supposed to signify it's okay, we can do this, we're working, not we're just going off the trail. But what happens sometimes is people see the orange vest, and what are you doing? They want to find out. And so, you know, varying degrees of the orange vest working. But, so yeah, it's not high impact like, you know, a city park or a wheat field or something, but it's high impact.
So you have more of a control for studying the actual effects of
Yes.
climate as determined.
Yes, definitely. Yeah.
All right, we've got time for 2 more questions, relatively brief ones. Yes.
So my field is environmental philosophy, and it's the pristine issue is a huge debate in environmental philosophy. And obviously there are problems with dating it back to a pre-European restoration status. So, especially because indigenous people did alter the landscape
Yes.
quite a bit.
Yes.
So, and especially because there is no environment because of climate change and acid rain and whatnot. There is no environment that's been completely unaffected by humans. So I suppose what I'm asking is, how important is it that we restore an environment back to the relatively indigenous species over measuring it by something like, you know, how the ecosystem functions together and biodiversity, and some other, you know, way
basically with restoration, we really should just start, give a good kick to nature, and if we actually start to focus on those pioneer species that I told you, and we actually give a good start for succession, they should be able, I mean, if the area is not somewhere really far from natural environments, those protocols will come as the site develops. So I would really just start mimicking what nature does in the same way, and I would not start with agricultural grasses, what actually is done a lot here at U, like bringing something in first of all, a non-native grass, agricultural grass, and then we actually are told our task is now to diversify. Here you go. So one of my students actually is figuring out that it's actually, the grass is allelopathic and it actually forms such a physical barrier that no native plants, not even no native plants, can actually take up the bottle. So that is right. And I would again just say be short, start a good succession, and that would be my first goal.
I would like to ask, one thing that's interesting is that many plant seeds can live for a very, very long time.
That's the other thing.
They go back hundreds and hundreds of years, and they might still be in the soil in some of those places.
There is actually theories that say that, well, you can do anything with restoration. You can put the best seed mixes in, you can spend millions of dollars buying new. But in the end, really, something will win what really belongs. Like, if you want it to be a Clarkia field forever, it's not possible, of course. Or even if you want to include Clarkia and it's not suitable for Clarkia, it will just go away anyways. So it's not worth the effort.
Right. And certainly I promote restoration because my discipline spends a lot of time sitting around talking about it and not doing anything. So.
All right. Hey, is it a quick one, Luke?
Yeah, I was just curious, this is a question for Robert regarding some of the phenotypes for the mycorrhiza inoculations that you're using. Are you using locally adapted mycorrhiza phenotypes?
So I didn't want to put too many figures in, but we actually have, in another place, so this only showed to you if we apply mycorrhizae, what would we experience. But actually we have a student who was crazy enough and now he has an experiment of testing 4 different mycorrhizae, and one of them is just kind of a control from out here. And we actually, for some species, we're finding far better results just to actually give a little hint from the soil from here because it's loaded with mycorrhizae. The bad thing about it would be that it has no pathogens. And in a species that I told you we didn't like it, actually, we experience so much mortality because we probably introduced some bacteria or fungi with it. So, but there is differences, definitely.
All right, ladies and gentlemen, I know you have more questions. Please feel free to grab these guys out in the lobby or wherever you find them. Are you guys hanging out this evening?
For a while.
For a bit. All right. Thank you so much.